Okay, good morning, guys. We are going to look at this number one question on tutorial sheet 2, which is on wastewater treatment plant design, and the question 1, which is highlighted on the screen, is talking about the first unit of treatment, which is screening. Screening aims at removing large particles found in the wastewater. So the question read thus: a mechanical screen bar or bar screen is to be used in an approach channel with a maximum velocity of 0.64 meters per second. The bars are 10 millimeters thick and the openings are 30 millimeters wide. Determine Roman 1 the velocity between bars and Roman 2 the head loss. So straight away we'll be talking, listen out the data provided. So we say excuse me. Okay, so solution. Okay, so we'll go straight to data provided. So say data. We have maximum velocity Vmax, which is 0.64 meters per second. We have a thickness of bar, T bar, which is 10 millimeters, and spacing between bars, S bar, which is 30 millimeters. So a screen is always, the screen is always rectangular, and it looks like that. So we have a channel, open channel, and then screen placed at a certain angle, call it theta, which is not relevant for this particular problem. So we have water flowing towards this direction, and then water flowing between the bars. Okay, so water flowing towards the approach channel, we can call that cure A, and flow between bars, we can call that cure B. So we say if cure A equals cure B, okay, but cure, as we know it, for a rectangular channel, flow to a channel is AVA is the cross-sectional area of the channel. It can be rectangular, it can be circular, but in this case is rectangular, and the velocity in the channel. That said, with cure A equals cure B, that's approach flow in the cross section of the channel equals flow between bars. It implies here that AC is the cross sectional area of channel times VA is the approach velocity, is therefore equals to A net, which is the net area of the screen, times VB, which is approach velocity, and that is what we are looking for. We are looking for approach velocity VB. So but A net, let's define A net. A net, that's net cross-sectional net area of the screen. A net is given as AC into spacing between bars all over thickness of bar plus spacing between bars. This will imply A net will be equals A net will be equals AC into 30 millimeters on 10 millimeters plus 30 millimeters. If we summarize that, then we're left with AC into 3 on 4. So therefore, if we intersect that in this formula, we say therefore AC VA, that's approach velocity, becomes we have already defined A net, which is AC into 3 on 4 times VB. VB is approach velocity. That's what we are looking for. And straight from there, you can easily observe that AC will cancel AC. Okay, so we are left with VA equals 3 on 4 VB. So VB becomes 4 VA. VA is 0.64 in order on 3. So this gives us 0.85 meters per second. So this is velocity. We say velocity between bars, which is supposed to be less than or equals to 0.9 meters per second. So it is okay.